Right, so the book just slaps these up and says, oh, these are useful. I thought we'd go ahead and integrate a few of them, and they turned out to be, some of them a little bit challenging, right? But all of this is, there's no real new material here, except it's combining material, right? Combining material. So, so Jesus, you a Red Sox fan?
Yes, sir.
Good. I used to live in Boston.
Really?
Met my wife in Boston. I'm not a big baseball fan. I'm not a sports fan of any kind, really, that much. But I've been to several games in Fenway. I've seen home runs hit on Lansdowne Street over the big green monster.
I want to go before they turn it on. It's old.
Yeah, it's old. Yeah, they're probably going. Then there's that little hill in left field, a slight hill. And the field, the outfield is not completely flat in left field. There's a little tiny hill, and as you know, running for a ball or something that factors into how fast you can get there. Okay, so we went through a bunch of techniques. Right, this was the big thing last time. Three integrals that differed only by the x in the top. 3x squared. A and C turned out to be similar, but again, lots of little techniques here. The dividing the excuse me, this long polynomial division, right? In order to make it that, which is something we know how to integrate. Knowing what integrates to say arctan or arcsec, right? Couple more we did last time. This right here is just a flat trick, dividing everything by e to the minus x. And what that does is you only have one e to the x in the original problem, but the top doesn't have an e to the x. And it would need an e to the x in order to make it look like the derivative of the bottom. But when you divide through by e to the x, the top and bottom both wind up with an e to the minus x. And fortunately, e to the minus x is the derivative of e to the minus x if you put a negative in front of it. And then, of course, you got that 2. All right, so, oh, yeah, completing a square, got that one. Algebra techniques. But it wasn't just algebra, though, because, I mean, this part was algebra, of course, getting to here. But then you got to be able to recognize, once you do that, that goes to this. The arc sine. Yeah. All right. Actually, there's one like this in the up on the sheet. Okay. We're on slide 9. Let's go up here. Right. Oh, we did. Right here. We had 1 over 1 plus sine. That's 1 over 1 plus secant. What do? We multiplied by the conjugate of the bottom. So that's what we're going to do here. We're going to multiply by the conjugate. So that's going to be multiply by 1. 1 minus secant theta. 1 minus secant theta. Right. Now I'm going to have a trig pop quiz here in a minute. Pop quiz for trig here in a second. Ready? Multiply those. Top. The bottom is difference of squares. A plus b, a minus b is the first thing squared minus the second thing squared. Pop quiz. What do you do next? Here's the pop quiz. I'm going to start the timer here in a minute, right? This equals, right? So go over to my little, oh, we got the chip and jingle already. Here we go, ready? What does that equal? Boom, boom, boom. If you don't remember anything about trig, you got to remember this. If you don't remember anything about trig, you got to remember that. Now, let's suppose you're stuck. I need to get a secant squared. How do I get a secant squared here? I'm going to divide through by something. Well, I'm going to get a secant squared if I take this 1 squared, 1, and divide it by cosine squared. So that tells me to divide everything through by cosine squared. Okay. Sine squared divided by cosine squared is tangent squared. We've done this already, by the way. Cosine squared divided by cosine squared is 1. 1 divided by cosine squared is secant squared. Okay. Now, out of that, I need to get 1 minus secant squared. So tangent squared theta is secant squared theta minus 1. So 1 minus secant squared is the negative of that. So 1 minus secant squared theta is the negative of tangent squared. So the answer is minus tangent squared theta. And I don't want to discourage you, but if you can't, if you don't have that on your Swiss Army knife, the problem ends right there for you. The problem ends. The trig's got to be there. Right? So I wind up with 1 minus secant theta divided by negative tangent squared theta. 2 theta. Now, I like getting rid of negative signs because I tend to drop, you will tend to drop negative signs, right? Especially if they're leading negative signs, you'll tend to drop them. And so, just to keep things sane, I'm going to write an extra step and do secant. Get rid of the negative sign and switch the order of the top. Okay. Switch the order of the top. How do you deal with that? This was one of the early. Back here. Remember, we're on slide 9. Back way to there. Where did we do this? We split up the top. That's one thing we did, right? And there's, in other words, we took this top, split it up. You can always split the top. You can't split the bottom, right? So down here, we're gonna have another pop quiz. Secant squared divided by tangent squared. Minus 1 divided by tangent.
Where you got the secant square? Isn't it supposed to be secant?
Oh, yeah. Hold on here. Ooh, you know what? Hang on. You are correct. Thank you. So that goes away. This goes away. Split up the top. Here's your pop quiz. What does that mean? This equals what? Integral. What does this equal? Actually, do it this way. Right? What does that equal? Secant is 1 over cosine. So break everything down to sines and cosines. How did you do? Break everything down to sines and cosines. You'll be able to do this quicker than I'm doing it now. I'm putting in extra steps so that you can understand where things are coming from. All right. So invert and multiply in both of those. Invert and multiply. So the first one is 1 over cosine. Invert the bottom and multiply. That's cosine squared over sine squared theta minus cosine squared theta over sine squared theta. Wait a minute. I don't like my, I don't like what I have on my paper. No, I don't like it at all what I have on my paper. All right. Yeah. Anyway, so what do we have? We're going to have this, that cosine cancels with that. Right? And then do we do with this cosine squared business here? We have something here. Let's see, go to my trig formula, trig card here. Where is that rascal? Okay. All right. On your trig table, I'm going to put this in here. This is going to be, let's just write one more step first. Let's see the problem. This is going to be a cosine in the top and sine in the bottom, sine squared. So that's going to be integral sine theta to the minus 2. That's sine squared in the bottom times a cosine in the top. All right. Cosine in the top. Brackets. Minus, this is cotangent squared. All right. Cotangent squared. Question. How do you integrate those? Well, the first one genuinely ought to be pretty easy. This is a function to a power, and the derivative of the inside sitting on the outside. That's why I wrote it that way. Function, sine, to a power minus 2, and the derivative of the inside is on the outside. So what does that integrate to? That's going to be, that integrates to sine theta to the minus 1 divided by minus 1. Cotangent squared is a bit ugly. But you got to remember a trig formula. Up here. Another one. Everything starts with this guy right here. I have cotangent squared. How can I get cotangent squared out of that? Well, cotangent squared is cosine squared divided by sine squared right here. If I take that whole thing and divide by sine squared. So, divide by sine squared, I'm going to have sine squared theta plus cosine squared theta 1. Now I need to divide by sine squared. And that gives me 1 plus cotangent squared equals cosecant squared. 1 over sine squared is cosecant squared. So cotangent squared is cosecant squared minus 1. How does that help us? I have a minus integral, and for cotangent squared, I'm going to put cosecant squared minus 1. So I'm going to have how is that any better? The antiderivative of -1 is theta. Right? What's the antiderivative of cosecant squared? A little thing here. The formula table, where's that? The guy right there. The derivative of cotangent is minus cosecant. So, like I said, the derivatives here are the key. They are the key. So, if you know the derivatives, this is the antiderivatives. Up here are the derivatives. The derivative up here of cotangent, right here. The derivative of cotangent is minus cosecant squared. So the integral of cosecant squared is minus cotangent. And that's the same, that's down here. So it's that. So go here. This is going to be, this is going to be minus, this is interesting. What does this simplify to? 1 over sine, this is going to be, oh, don't tell me.
Cosecant.
If I lose this work, I'm not going to be happy. I'm still not going to be happy. This is like our first slide. And we've already written too much. Okay. Um, here. Slide 9. Here's a moment of truth. Ready? Oh, it doesn't look good. No. We lost a bunch. All right. Actually, you know what? This is interesting. Watch this. Watch this. That's the part I don't have a picture of. So we go over here. And I clip. Oh, perfect. And this right here. There. And you see how those actually match, right? We got a little smaller. Oh, a little smaller. That's close. That's close. Okay? Close enough. All right? That's a tangent squared in the bottom right there. Okay? This is our work. Sorry. Yeah. Save that. So this guy right here, sine to the -1 is, we've already done it here, cosecant. So this is minus cosecant. Minus the antiderivative. What's the antiderivative of cosecant squared? Minus cotangent. Minus cotangent. Not squared. What's the antiderivative of minus 1? Minus theta. And that equals minus cosecant plus cotangent plus theta plus c. Yeah. So these are just using those basic integration or actually algebra techniques. Do something here. Move this over a little bit. Right? What the book calls that first table, those are basic rules. This one, look how many steps. All right. But this is how chapter 8 goes. This is how chapter 8 goes. And there's what are the hot spots here? Hot spot number 1. Right here. Yeah. That's number 1. Hot spot number 2, recognizing this.
So y1 minus secant instead of 1 plus secant on the first hotspot.
Right here. These two multiply together, you have, when you have a plus b times a minus b, if you FOIL that out, you get a squared minus ab plus ab. So the cross terms cancel, minus b squared. So here we have 1 plus secant times 1 minus secant. By that rule, it's the first thing squared minus the second thing squared. It's a minus there. It's a good question. So that's hot spot number 2. All right. Down here, all we did is I got rid of the negative sign. That's not a big deal. Here, you split these up. You split up the numerator. Take each one into sines and cosines. Come down here. Do some canceling. I would say another hot spot here is this one. Writing this as this. Recognizing that this thing right here is a sine squared in the bottom to the minus 2. Cosine in the top. Now, there's another way you could have done that, all right? Another way you could have done that. I'll show you in a second. All right? And then this is cotangent squared. Then, well, how do you integrate cotangent? You got to go over here, get a hold of cotangent squared is 1 minus, see, so this right here, that is a definite hot spot there, man. That is a, so let's call this step here number, what is that, hot spot number 3 or 4, something like that. Right? Now notice, this came out to be minus cosecant. This did. Minus cosecant. Another way we could have done some of this is Put a little asterisk there, and put an asterisk here. Red asterisk right here. Okay. I had cosine over sine squared. So integral cosine theta over sine squared theta d theta. That came out to minus cosecant, the way we did it, right? Another thing you can do is write this like this. Break this up into 1 over sine theta times cosine theta over sine theta, d theta. So you break that up into 2. What's 1 over sine? Cosecant. What's cosine over sine? Cotangent. The derivative of what is cosecant cotangent? That's on the table.
Negative.
Close.
Negative.
He's right on the negative part. What here are the derivatives?
Secant.
Close. Right here. The derivative of cosecant is minus cosecant cotangent. So the integral of cosecant cotangent is minus cosecant. And that will be down here at the bottom somewhere. Right? What do we got here? Derivative. Right here. Right there. Number 15. Remember yesterday was 16, 17, 18? Yesterday. Of course, Friday, yesterday means Wednesday. Remember 16, 17, 18? Now we're using this one. So the antiderivative of cosecant cotangent is minus cosecant. Because the derivative of cosecant is minus cosecant cotangent. The core to all this, the key to success in calculus, is an ice-cold mastery of derivatives. Ice cold. Ice cold. You can't be stumbling over those. And so right here, that is minus cosecant theta plus c, which is the same thing we got. That's the same thing we got right here. That was the same thing we got here. We did it a different way. We made it sine to a power times its derivative. You got the same thing. Right? Do I care which way you do it on a test? Nope. I just care that you can do it. Yeah. Here's another problem. Go through every single molecule of toner on your paper. And I want to tell you, if you're studying this somewhere, that could be a good solid hour, maybe more, that you're staring at one problem, because it contains these different skills. So you're not studying just one skill, right? You're not studying just one skill. You're studying all the different things. This brings in a lot. And chapter 8, this is chapter 8. The whole chapter gets in. It's just that way. All right, here's some love for you. We'll make this due after the test. Right, test on Monday. Right. I got your appointment set up from over there. Right. Yeah.
So I have a question.
Hmm?
So all the homework, do we turn it in after all the tests?
You should have they're due the next day. They're due to the next class period. So the last day I'll take it at all is test day. So whenever we pass a slide in class, that homework is due the next period. So if I pass one on Wednesday, it's due Friday. I pass one on Monday, it's due Tuesday. The whole idea is for me to force you, coerce you, bribe you to look at it between class periods. Because every class we pass at least one homework. So that way a person has to look at it a little bit between class periods. That's the whole idea. The last day I'll take chapter 7 homework at all is Monday. So turn in whatever homework you want for chapter 7 on Monday, you'll get some credit. If it's really late, it'll be less than 4 credit. Integration by parts. Yay. All that was one section. One section. Yeah, so this is integration by part. The good part is we've done this before. I won't give you anything on the test, chapter 7 test, that involves by parts or that absolutely needs by parts. But chapter 8, it's a whole different story. Parts comes up all the time. And this is the formula we've been using. And I told you before, it derives from the product rule. This is the product rule. So you integrate across that. And then you switch things around. You put UV prime on the left. The integral, and let me back up here. The integral of a derivative is just a function. Now, we're going to put this guy here on the left. That'll be and that is the same as that. Now, think of this right here as V prime. Right? The rule of thumb is, if I want to crack this integral here on the left, I got u v prime, I'm going to need v. So I got to integrate whatever I pick to be v prime, I have to integrate. So v prime's got to be something I know how to integrate. And then I'm going to take the derivative of u. For u, I need u prime over here. That's a derivative. So down at the bottom, these are rules of thumb. And I'm a math guy. Should be rules of. So you're going to make, since you have to differentiate u, you would like to make u something whose derivative is simpler. And then make v prime the hardest thing you know how to integrate. So to do integration by parts, you've got to have a product of some kind. Something to call u and something to call v prime. And those are two rules. Now, there are going to be moments when only one of these applies. You know, the ideal world is when they both apply. And every time we've done it so far has been the ideal case. We're both applied. We picked something that got easier when you differentiated it. We picked something else that got that was the hardest thing we knew how to integrate, and we knew how to integrate that. There are going to be times when neither one of them is true. Where neither function, you got a product of functions, neither function gets easier when you differentiate it. And neither one is easy to integrate. We're going to have them. We're going to have them. But we have a few ninja moves that we can try in those cases. They're ninja, they're secret. Right? Roaring lion, crouching tiger. Hi-ya! Right? All right. Guidelines, that's what I just said. This one's a classic. It's in every single calculus book. You can't teach integration by parts without this example. Now, if it were just e to the x, what's the antiderivative of just e to the x? E to the x. That's why we like e to the x. It's its own derivative. So, but we have that extra x there. Perfect. You go over here, and you're going to pick something to be u and something to be v prime. I have a product there. Which of those two gets easier when I differentiate? X or e to the x? X. Its derivative is 1.
That was easy.
I hate that button. V prime is e to the x. Of those two, what's the harder one that I know how to integrate? E to the x. V is e to the x. Okay. All right. So, just to go over here, I picked this to be my u, and I picked this one to be my v prime. Right? So this is going to equal, according to the formula, uv. So I'm going to have uv minus the integral v u prime. So what's u times v? U times v is x e to the x. Minus the integral v u prime. V is e to the x times 1. Naturally, you don't have to put times 1 there. Okay, I'm doing it for emphasis here. Okay. Well, so the first one's already kind of integrated. You don't have to do that, but you have to do this integral. And it's minus, by the way. Now, sometimes this will include a minus that will make that a positive. Okay. What's the integral of e to the x? Dx. That's parts. And we've done that a couple times. We had an x sine x. We're going to have one here like that. Questions on that?
It looks easy, but when it comes to a problem, it's hard.
Yeah. Well, it's sort of like, well, like anything you're practicing.
So we can do like u be e to the x2.
UV, well, I don't think that would help. Like, for example, let's just go that way. Suppose you did it different. Suppose you did u. Sorry. Suppose you made u e to the x and v x. Suppose you did it the other way. Well, the derivative u prime is the x. This antiderivative v is x squared 2. So in that case, integral x e to the x dx would be uv, that times that, minus the integral of these two. And so this integral is even more of a mess than you started with. Right? So yeah, that gets you in the wrong direction. So if you see an integral that's more of a mess than you started with, try switching them around. So this is a bigger mess. E to the x sine x. Now it's time for our first special case. We're going to be doing a bunch of these, okay? Our first special case is e to the x sine x. Okay, so now, question. Which one gets easier when you differentiate it? And which one's the hardest thing we know how to integrate?
E to the X.
E to the X is what?
The easier to integrate.
Easiest to integrate?
No.
Differentiate. Okay. So we're going to do U, E to the X. V prime is sine X. U prime is E to the X. V is the antiderivative of sine.
1 minus cosine.
Sine squared is 1 minus cosine, but that's not the integral.
Cos minus cosine.
Yeah. Not a home run, but that's a ground rule double, okay? That's a ground rule double. Right?
You have pictures in the Fenway Park?
What's that?
Do you have pictures in the Fenway Park?
In the family?
Fenway.
Oh, Fenway Park. Oh, I don't have pictures of me. No. Well, you know what? I might back there somewhere. I lived there before digital cameras, so they'd be prints, right? I lived there in the late 80s, early 90s. I met and married my wife. I met my wife for the first time just a few blocks from Fenway Park. There was a hotel called the Heinz Center. It was a convention center. First time I ever laid eyes on my wife. And so we met and were married in Boston. But we left Boston in 91. So 30 years ago. Was one time a game there that went 14 innings. Got done like 1:30 in the morning. All right, so this is going to be UV minus e to the x cosine x, right? By the way, we picked in this case UV prime. So, and this is going to be UV minus integral V du. So minus the integral of V minus cosine times e to the x. So it's minus cosine. Whoa, wait a minute. Let's cancel. So I'm going to get
Why you put that negative in front of the EX?
right here.
No, the first one.
There?
At the beginning of the pro. No, over here.
Here.
Yeah.
Oh, yeah. This one. That's going to be UV. So that negative is this negative here. So that's UV together.
Oh, okay. Yes.
So there's a negative on that. So how do you integrate this? Parts again. You do parts again. Because look, this looks a lot like that. Doesn't this look like that? Except with the cosine. Here's the trick. You're going to do parts again. Whatever you picked to be u the first time, pick that to be u the second time. So if you picked e to the x, we're going to pick e to the x to be u. So we're going to do parts again here. Make that e to the x again. U prime, e to the x. V is going to be cosine x. So we're going to make this the u, and this the v prime. The antiderivative of cosine is?
Negative sign.
Close.
Negative tangent. I don't know.
Okay. Negative sign was close. I'm going to have my lovely and talented assistant help you out. Negative sign, he said, I asked him what the antiderivative of cosine was. He said negative sign, that is close. It's a lot better than negative tangent or whatever he said. So negative sign is close. The derivative of what? Yeah, ask yourself, the derivative of what is cosine? Sine.
I was gonna-
Sine.
I don't know what-
Right? 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 You overthrew second base. She backed you up in left field, threw him out at third. Okay? All right? Okay, good. So what we're going to do is have you guys take the test together. Okay? So this is going to be plus UV minus the integral of V to U well, a lot of good that did. Because now we have to integrate this thing down here, and that's what we started with. We went in a full circle. See, that's the same thing we started with. And the whole point is I didn't know how to integrate that. Here's what we're going to do. Okay. What's the left side here? Left side is this. Well, they don't cancel. The good part is if this were a plus, it'd cancel, and that would equal 0. You'd be stuck. The good part is they don't cancel. That can come over here to the left. It can join this guy over here. So this becomes, you ready? Very important. 2 times our integral. So we got the negative of our integral over here. That is actually good, as long as it's the negative of your original integral. Because if it's the positive of your original integral, it's the original integral, and they cancel off on both sides. So this guy comes over here. Both of you see that. So to get my answer, I just divide by 2. And we are going to exit this. Let's cut that down. We're going to exit this and get back to it because I have written a lot. I don't want this. I don't want to crash. Okay. Exit. So much easier to do it before we crash. Those, if you didn't get a chance to copy it down. Right? So keep this trick in mind. The problem here, what created the problem, is e to the x just stays e to the x. Whether you integrate or differentiate, e to the x stays e to the x. Sine goes sine, cosine. The derivative of cosine is negative sine. Derivative of negative sine is negative cosine. Derivative of negative cosine is positive sine. So this cycles through those 4 derivatives. Sine, cosine, negative cosine, positive sine. And it starts over again. Neither one of these ever get any simpler. Or for that matter, they don't get any more complicated either. So when you have that situation, you pick one of them. By the way, we could have switched these two around. For your question last time, we could have switched these two.
What are we gonna do right here? This is an encore solution.
Oh, there you go. Encore solution. Encore. There we go. We can switch these. So we can do, if we want to, u sine x du cosine x. Oops. Okay, v prime. V prime is e to the x. V is e to the x. That's going to be uv minus integral v du. So we switched what we chose for u and v prime. And we got another integral that's similar. What was the key last time? The first key? Whatever you picked to be the u the first time, in this case the trig function, we're going to pick this to be the u the second time. So u, don't pick u to be u to the x here. So you're going to get cosine x. U prime is minus sine x. V prime, e to the x. V, e to the x. That equals e to the x sine x minus bracket uv e to the x cosine x minus integral v to u. And that makes that cancels with that. We have triple negatives here. And then this is a negative of that. That's our original integral, right? So that makes, again, a 2 integral e to the x sine x is divide by 2. Parts. When it works, it's a lifesaver. Most students wind up liking integration by parts. Okay. Right? And that's the same, by the way, as we got right here. That's the same as that. All right. This one is deceptively simple. First of all, what's the antiderivative of log? Natural log x. Answer? I don't know. It's not on our table. The derivative of what is natural log x? Okay, we're in the parts section. That should be a hint. But we're in the parts section. So it's like the hardware store. We're in the parts store. What do I pick to be u, and what do I pick to be du? Or uv prime. I need to pick u. And pick v prime. Well, I only have one thing, log x. 1. 1. Now, I want something that gets simpler when I do. I don't know how to integrate this. That's the whole point. So I can't make log x my v prime because I don't know how to integrate it. I've got to make log x right here. And v prime, I'm going to make 1. Because, so imagine this as being a 1 times log x. And make the 1 the v prime. So the derivative of log x is 1 over x. The integral of 1 is, and the derivative of 1 is x. That's going to be uv. uv is x log x minus integral v du. The integral of v du is x times 1 over x. That's the integral of 1. This is x. It's 1 dx. And so that comes to be x, natural log of x. What's the antiderivative of 1? X. So don't be afraid to be a little bit creative and make your v prime sometimes 1.
What about 0?
Well, what's the antiderivative of 0?
A number. Bless you.
What's the antiderivative of 0? The derivative of what is 0? So it'll just be a constant. So that would give you some constant up there. It won't work. Yeah. Another thing, okay, here's another reason. You don't have a 0 here. If it were 0 times log x, it wouldn't be log x. So you don't have one of them here to make 0 equal to 0. All right. All right, that is a sweetheart there. This one is one of the stickiest integrals in calculus, right here. Secant cubed. We're not going to do it today, of course.
Can you go back to
Secant cubed, we're going to do next time, meaning next Wednesday. Secant cubed, we're done. Secant cubed is another one of those nasty integrals you're either going to need to what? And you hate when I say this. I don't blame you for hating it. You're either going to need to memorize or know how to get it, and it's long and ugly. It's a long thing to memorize. Either remember it or know how to get it. Now, you remember the integral of secant, right? The integral of just secant is natural log absolute value of secant x plus tangent x plus c. The integral of secant squared is tangent, right? The integral of secant cubed is next Wednesday. See ya. Have a good weekend. Go out and get some sun. Oh, I even started the recording today.